now we are going to continue with the chapter 14 dedicated to generators in our marine electrical handbook. The chapter 14 is basically generators, generator installations, calculations, and troubleshoot. In this episode, we are going to be focused on the output voltage, high output voltage, low output voltage, and how to fix it and how to verify what is the problem and what is the solution, if there is a solution or not. We are going to check the procedure in the page 250, 251, 52, the procedure to use the megohmmeter, and the procedure to check the quality of the insulation in the back end using the megohmmeter. In the previous episode, we talked about the frequency, and I explained in that episode the process to calibrate the frequency. If the frequency is too low, normally it's a mechanical problem related with fuel or gas. If the frequency is too high, normally it's a problem at the governor of the fuel injection pump. It's a mechanical problem on the engine. High RPMs, overspeed. This is normally a problem on the governor of the fuel injection pump for diesel engines. For gasoline engines, normally you have a low frequency problem, no high frequency. If you have high frequency, probably it's also on the governor of the throttle body. But it's more common high frequency problems related with the diesel generators. Okay, in this episode, we are going to be focused in the voltage, in the output voltage produced for the generator. There are different scenarios. One scenario is my generator is produced a little higher voltage. It's 130, 135 volts in each phase. Normally it's 120, and that generator is producing 130. If the increment is 10% over or 10% lower, you can fix it checking the voltage regulator. Remember, I explained before, immediately the generator produces the AC power on the back end. The cables with the AC power enter in this equipment. This is the voltage regulator. The hot, the neutral, and the ground enter into the voltage regulator, and the voltage regulator regulates the voltage, keep the voltage stable, and this is the output, and those cables enter into the breaker. This is the voltage regulator. All the generators, they have a voltage regulators. All the voltage regulators, they have three spots. One spot to calculate voltage, other spot to calculate the gain, and other spot to calculate the stability. This is the voltage regulator and is used only to calibrate voltage, no frequency. The frequency is related with RPMs and should be calibrated at the governor or a throttle body. Is basically RPMs on the engine. Never try to fix it frequency problems with the voltage regulator. There are a couple of manufacturers that they put in one of those spots frequency, but it's not common. I am going to explain later why and how you fix it, the voltage here. Okay, this is the voltage regulator. The power coming from the back end enter here. The regulator regulates the voltage, and the power goes out into the breaker of the generator, that breaker. And after that, the power, hot, neutral, and ground, goes into the AC band. If the voltage, if the increment or decrement is more or less 10%, you can adjust with a small screwdriver in the first spot. The first spot is volts. This is to calibrate high voltage or low voltage if the increment is no more than 10%. For example, in this moment, the reading in my voltmeter is 127 volts and 28 volts. It's a little higher. I can adjust, of course, with the engine running. I connect my voltmeter in the terminals of the breaker, and with the generator running with a small screwdriver, flat screwdriver, I adjust the spot volts. And I check the voltage, 126, 124, 120, perfect. And now, with the voltage 120, I turn on the breaker again and I apply loads and I verify if the voltage stays 120. The second spot is basically stabilization. Is when the output voltage is moving up and down, is not stable. With the second spot, you adjust slowly the stabilization, and you check all the time the voltage, if the voltage is going up or down. In order to calibrate stabilizations, I recommend use, instead of the digital multimeter, use an analog multimeter, because the analog multimeter with the needle is easy to identify if the voltage is fluctuating or is stable. I prefer calibrate the second one, the stabilization, with an analog multimeter, because with the digital it's not easy verify if the output is perfect stable. Okay, the first one is to calibrate output voltage, high or lower, no more than 10%. The second one, stabilization, is used to calibrate if the voltage is fluctuating. And the third one is related with the gain. What is the meaning of gain? Gain is the time that the generator spends to recover the maximum RPMs. Let me explain something. Normally, when you apply loads on the panel, you hear that the generator decrease the RPM a little and immediately recover the RPMs. That procedure normally takes a couple of milliseconds. You apply the load, the generator decrease the RPMs and immediately recover the RPMs. In some cases, when the load is too heavy, when you apply the load on the breaker, you hear that the RPM decrease and recover, but immediately recover the maximum RPMs. If suddenly the generator, when you apply heavy loads, spend more time than the recommended to recover the RPMs, you need to adjust the third button, the third spot, gain. Exactly the same with a small screwdriver. You adjust a little high or lower, of course, with the generator running and with the load applied. You turn off the load, you apply the load again, and you hear if the generator recovers easily. If not, you adjust a little more until the gain is adjusted. Be careful, because adjust the gain is not related with adjustment of frequency. Frequency is completely different, it's not related with gain. Some people confuse both terms. Gain is the time that the generator requires to recover the maximum RPMs. That's completely different. Once again, in the voltage regulator, we have three spots. One spot to calibrate output voltage, higher or lower, no more than 10%. The second spot, stabilization, is used to calibrate fluctuation in the output voltage. And the third spot is gain, is used to calibrate the time to recover the RPMs. This is the voltage regulator. Okay, suppose that the complaint of the customer is the voltage, the output voltage of my generator is 50 volts in each phase. No 120, 50. It's too much. Never try to calibrate those output voltage, low voltage, with the voltage regulator, because you damage the voltage regulator. If you continue increasing, you explode the voltage regulator, and now you need to replace the voltage regulator and probably the winding, because the winding is damaged. Never try to adjust output voltage with the voltage regulator if the difference is more than 10%. The voltage regulator is good for a small difference, no more than 10%. Okay, if the difference is more than 10%, like 50 volts or 60 volts, you need verify the condition of the winding in order to be 100% sure that the winding is in good condition. Okay, what is the procedure? The procedure is using this equipment. This equipment is the megohmmeter. Mega ohms. Ohms is resistance. Ohms. With this equipment, we are going to check the quality of the insulation of the wires in the winding. The quality of the insulations in the winding. This equipment, when you crank it here, you apply a heavy voltage, high voltage on the winding. And with this equipment, you check how much is the resistance of that winding with that excessive voltage applied. Yeah, this equipment is used to check the quality of the winding, to check the resistance on the winding. There are two types of megometers. This one is completely mechanical, analog, and this one is a digital megometer. I love Fluke. Fluke is excellent. Fluke is very accurate. I recommend Fluke for voltmeters, and this one, the megometer, is excellent. It's a little expensive, but always I say to my students, in this business, in the marine business, you can recover the money easily if you are a professional technician. If you are responsible, if you are a good technician, you recover the money easily. This is an important equipment. You need this one, the digital, or this one, the analog, the mechanical. Both of them are okay. I use all the time this one. It's perfect. You found this equipment in eBay, in Amazon for $60, $50. This one is a little more expensive, around $800, but that's perfect. I love it. Both of them are okay. I recommend try to buy one of these, analog or digital. You need the megometer. If you are working with marine generators, if you are working with marine electricity, you need the megometer. Not only to check the back end of the generators. With the megometer, you can check any motor, three-phase motor, single-phase motor. You can check the winding of alternators. You can check any winding. The alternator, the star motor, the bow thrusters, any motor AC or DC can be checked with the megometer. The megometer is an equipment used to check the quality of the insulation in the winding of any motor or generator or equipment. I use it to check the motor of bow thrusters, the star motors, alternators, and of course, back end of generators. Okay, I have a couple of motors, AC motors, and also the back end of the generator, and I am going to explain in a simple way the procedure to use the megometer. Normally, for example, this is a single-phase motor. Remember, the single-phase motor always use capacitors. The capacitor is used in single-phase induction motors, AC motors, to produce an extra voltage at the beginning in order to produce extra torque. This is used normally in single-phase motor. In three-phase motor, you don't need capacitors. You have the phases in different angles, and the torque produced is excellent in comparison with the single phase. Is only like one piston to move the rotor. In this motor, three-phase, you have three different pistons in three different angles. It's easy, the movement and the speed of the shaft. All right, I am going to check, for example, in this motor, the condition of the winding. This is the hot, and this is the neutral, and the ground should be with any part of the case of the motor. I am going to check, first of all, with my digital megometer, and this is the procedure. I connect the negative side to any part of the ground, any part of the case of the motor, and the hot to the phase that I want to check. I am going to check the hot right now. I am going to apply 500 volts. 500 volts for 10 seconds, and I am going to check is 23 mega ohms. 23 mega ohms. And now I am going to do the same procedure with my analog my analog megohmmeter. The ground to the case of the motor and the hot to the other one. And now this is 0 mega ohms. If the needle goes to this side, this is the maximum, this is infinite, and this is 0. Normally, the winding of any equipment, any motor or generator is good if the resistance is pretty close to 1000 mega ohms. More than 1000 mega ohms is excellent. A little before of 1000 is in operational condition, but it's not perfect. And less than 1500, 400 mega ohms is not good. Of course, if the reading is 0, it's because the winding is open. Once again, the magic number is 1000 mega ohms. Pretty close to 1000 is working, but it's not perfect. More than 1000 mega ohms is excellent. For that reason, the majority of the megohmmeters analog like this, the needle in this direction goes after 1000 mega ohms, they have the symbol of infinite. Okay, if the needle goes to infinite, it's because the winding is in good condition. If during the cranking the needle is going to 0, it's because the winding is out. Okay, we are going to check. They have they have 0 in this side, infinite in the other one, and they have the marks in mega ohms: 1 mega ohms, 2, 10, 20, 100, 200, 300, 500, 1000, and infinite. Okay, I am going to check right now in this equipment how much is the reading when I crank it. When I crank it, it stayed in 20. What is the meaning of that? It's not good. 20. This one is 23. This is more accurate. This one, the needle is around 20, indicating that it's less than 1000. It's not good. I can check the other phase. The other phase. Once again, around 20. That's not good. If I check with the analog, with the digital, should be exactly the same. I can use this equipment to check three-phase motor. For example, I am going to check with this digital megohmmeter this three-phase motor. I have the ground here, and I have the phases here. I am going to check the phase number 1. I am going to check the phase number 1, and I am going to show to yours. I can apply 1000 volts, 500, 250, 100. I am going to apply 500 volts, and I am going to apply the test. Some seconds is 543 mega ohms. 543 is not good. The minimum should be 1000. Okay, this phase is not good. Let me check other phase. I turn it off. Once again, I select 500. And now I apply voltage in other phase, in the phase number 2. One connected to the phase and the other one connected to the ground, the case of the motor. And I apply the test. 278 mega ohms. That phase is not good. With only one phase not good, the motor is not good. Exactly the same with the generator. I am going to check phase by phase. If one phase is not good, you need replace the back end or rewind the back end. Is possible rewind the back end? Yes, it's possible. But normally, in my experience, I explain to the customer. I say to the customer, we can separate the back end. We can send the back end to the machine shop. The machine shop rewind the back end, and I put again the back end with the engine, and you have generator for other amount of time. But I don't recommend, because that equipment, the generator, is designed to run engine and generator for some amount of hours. If right now the back end is out, it's an indication that in a couple of months the engines will be broken. Okay, you repair the back end. The back end right now is like new one, but you have the old engine. Probably in 6 months, the engine is out, it's broken. Low compression, or one piston is broken, or any mechanical problem, and you need to repair the engine. And now, if you added the reparation of the back end, the reparation of the engine, this is more expensive than replace the generator for a big one.